Hello everyone, we are from group 5. In here we are going to presentation about test item analysis empirically with member Annisa Sekar Ayu with ID number 003, Lailatul Nurul Afidah with ID number 039, and Siti Malihatus Saniyah with ID number 114. First is the test item analysis empirically. Test item analysis empirically, also known as a quantitative analysis. Quantitative study of question is the study of item based on empirical data from the items in question. This empirical data is obtained from the questions that have been tested. There are two approaches in quantitative analysis, namely the classical and modern approaches. Classical item analysis is a process of reviewing information from student answer using classical test theory, while the modern approach is the study of item by using item response theory or IRT. This theory is a theory that uses mathematical function to link the opportunity to answer correctly and the ability of student. First is the item analysis according to classical theory. The advantage of classical test theory lies in its easy to understand concept and its use in small-scale tests. The core of classical test theory is in the form of mathematically formulated assumption, whose model is called the true score model. Classical test theory assumes that everyone has the correct value or true, which will be obtained if there is no error in the measurement. Then the aspect of the classical theory, first is the difficulty level. Difficulty level of an item is expressed by index called the item difficulty index and is symbolized by the letter P. Theoretically, it can be said that P is actually an empirical probability to pass a certain item for a certain group of students. In measuring test item, the item difficulty level is related to the percentage of people who can answer the question correctly. The price of the item difficulty level on the test kit can be determined by the following formula. Pi is equals to P over 2T, with Pi is item difficulty level, B is the number of the test takers who answer the question correctly, and T is the number of test takers who work on the questions. And this is the category item difficulty level. Next is the distinguishing power. Distinguishing power or distinguishing power of a question serves to determine whether or not a question can distinguish group in aspects that are measured according to the difference that exists in the group. This discrimination is also related to the how well an item can distinguish the ability of test taker. The item discriminatory index is basically an index on the items that can distinguish students who get high score from students who get low score. And the formula for determining discriminating power is TP equals to GBA minus GBB over 2 0,5 times GSA, with TP is a distinguishing power, GBA is the number of students in the upper group who answer correctly, GBB is the number of students in the lower group who answer correctly, and GSA is the number of students in the upper group. Then how to determine the number of group above and below the item analysis is, to determine the number of upper and lower group, first look at the total number of samples or students that are included. If the sample is more than 30 people, then you must take 27% of each student from its upper and lower group. Meanwhile, if the sample consists of at least 30 people and not more, then you must take 50% of each student from its upper and lower group. The discriminatory power index is determined from the difference in the proportions of respondents from each group. The index shows the suitability between the question function and the overall test function. This instinctive power index can be calculated by point biserial correlation and biserial correlation. And this is the category of acceptance of difference power items. Next is the deterrence function. The distractor analysis provides information on how many students in the upper and lower group choose each point option on multiple choice item. One purpose of problem analysis is to find out about the distribution of the subject answer to the available alternative answer. Through the distribution of answer can be known. First is the number of test takers who answer correctly. 2. Second is the distractor who were not selected by low ability test taker. Third is misleading distractor, and the fourth, the distractor who were attractive to low ability participants. A distractor is said to be good if it has a negative biserial point correlation value. A negative value indicates that students with low abilities tend to choose the distractor as the answer, whereas students with high abilities will choose the answer K as the answer.
Okay, next is reliability. Is the determination or consistency of a test when it is tested on some subject. The test is said to have high reliability, or there is high correlation between the result of the first test and the result of the second test if the test scores are the same. If there is no relationship between the result of the first test and the result of the second test, or the relationship is low, then the test is said to be unreliable. This is indicated by the level of consistency of the scores obtained by the subject measured with the same instrument or measured with the same instrument under different conditions. Next is measurement error. Measurement error or standard error of measurement help test user in understanding random errors that affect a test taker's score in the implementation of the test. The measurement error can be calculated by the following formula. That is, standard error of measurement is equal to sigma x times the root of 1 minus rho xx prime. When sigma x is standard deviation of the total score, rho xx prime is reliability coefficient. The characteristic of the item with the classical approach above have basic limitations. Among others, first, the parameter estimation result depend on the characteristic of the examinees or dependent group. This implies that the level of difficulty of the question will be low if the test is tested on a group of high ability test takers. On the contrary, if the test is tested on participants with low ability, the level of difficulty of the test will be high. Second, the result of the estimation of participants. Ability depend on the characteristic of the item or dependent item. Next is item analysis by item response theory or IRT. Based on weakness of classical test theory, a new test theory was developed, namely the modern test theory or item response theory or IRT, which was first raised by Lord in his dissertation on 1952. Modern item analysis is the study of item using IRT. The main purpose of IRT is to provide a similarity between item statistics and ability estimate. Several assumptions underlying the item response theory are one-dimensional unidimensional, meaning the dimension of the participant character are measured by a single test. This assumption is very difficult to fulfill because the many factors that affect the test such as cognitive, personality, and language. However, it can be assumed if in the analysis result there is one factor that is more dominant than the other factor. It can be said that the test is unidimensional. And second is local independence, meaning the test taker's response to an item is not related to the other item in the test. In general, the item response theory uses a logistic distribution model. several logistic models in item response theory, including first, a one-parameter logistic model, determined by one item characteristic, namely the level of difficulty. Second is a two-parameter logistic model, determined by two item characteristics, that is level of difficulty and discriminating power. And third is a triple logistic model. Parameters are determined by three characteristics, that is level of difficulty, discriminating power, and guessing factor. The two-parameter logistic model used in this logistic analysis uses the formula P theta is equal to E to the power of TAI times theta minus PI over 1 plus E to the power of TAI times theta minus PI, where I is equal to 1, 2, 3, etc. Information: P theta is probability of correctly answering item I by participants with ability. Theta is participant ability. E is transcendent number whose magnitude is close to 2,718. N is number of items in the test. AI is distinguishing power of item I. PI is item difficulty level I. D is scale factor, that is 1,732. Logistic model is used on the data with the dichotomous test item answer. This is aligned with IRT. Some aspects are characteristic of items that needed to be considered in the theory of the model and test. First is difficulty level. In item response theory, the difficulty index B is the same metric as skill or trait. Items that have a high level of difficulty have a difficult index of difficulty. According to Hamilton and Swaminathan, good difficulty index is between -2 until +2.
Okay, next is the aspect differential power. So, high discriminatory power can be interpreted that the item can discriminate between examines at various levels. In the item response theory, A is a symbol of the discriminative index, which is a measurement of the discriminative power of the claims. The index is sometimes called the slope because it shows how sharply the likelihood of a correct answer changing, such as an ability or trait increase. In the classical test theory and a good item response theory, a higher discriminatory value indicates a greater or good discrimination index. So according to Hamilton and Swaminathan, the discriminating power index is between 0 until 2. And then the next aspect is item fit with logistic model or goodness of fit statistic. So IRT can be released only if there is a match between the model used and the test data. The suitability of an item with a model can be seen from the chi-square value of the item compared to the critical price of the chi-square distribution, according to decay of the item concerned at a significant level of theta, where theta is equal to 0.01 or 0.05. Then the item is said to be suitable for the model if the chi-square value of the item is smaller than the chi-square distribution value at its critical value. And the next aspect is information function. In the analysis of modern test theory, it can be seen the function of test information and the ability of students. The test information function is the sum of the information functions of all items on the test at the ability level. According to Tally Estragon, test information function will vary according to the value of theta. At a certain value of theta, the value of the information function reaches its maximum. The maximum point means that if the item is done by the participant with the theta, the highest information will be obtained. In the two-parameter logistic model, the item information function satisfies the following equation. That is, big I theta equal to t square times a square times e power dA times theta minus b over square of 1 plus e power dA times theta minus b. For your information, d is the constant, whereas the value of d is 1.7, and theta is the ability scale, e is the Euler number, whereas the value of e equals to 2.71828. And A is differentiating power of the item, and B is item difficulty level. Okay, next aspect is standard error measurement, or SEM. The measurement error, according to the item response theory, is expressed by SEM, whose magnitude depends on the level of a person's ability and the function of the test information. The existence of error inherent in the measurement data is caused by many factors, including the measuring instrument itself, the implementation of the measurement, the object of measurement, and the analytical technique used. So the information function with the standard error of measurement, or we call it as SEM, has an inversely quadratic relationship. So the larger the value of the information function means the smaller the SEM and vice versa. So, for the form of the relationship between the two is formulated as follows, where SEM theta equal to 1 over the root square of I theta. So for your information, I theta is information function and SEM theta is standard error measurement. Okay, so here is the example of the result of item analysis with a classical approach. So we get the question number 1, 2, 3 up to 30. And then we have aspect reliability, distinguishing power, difficulty level, and deterrence function. So each aspect has index and interpretation. Okay, so that is from group 5 about the test item analysis empirically. So thank you for watching and see you.